Alright guys, thanks for tuning in. As you saw in my last video, I'm running the exact same benchmark for seeing what video rendering is like on different processors and different hardware, but really trying to compare different processors on the same hardware to see what's going to produce kind of the fastest render times. I've upgraded the actual AMD processor on this particular setup here right now with a 3700, so 2 more cores, 4 more threads. So we've updated to AMD Ryzen 7 3700X, and as you can see, it's a processor that's got 8 cores, 16 threads, base clock of 3.6 gigahertz. I've overclocked it to try to get the most out of it at this point, and we'll see what it can do for performance. So it says that the max boost clock is at 4.4 gigahertz, but I've got the PBO performance boost optimized algorithm turned on here. And so on this particular build, I mean, you might ask the question, why didn't I get a 3800 XT, which has a higher boost clock of 4.7 gigahertz and higher base clock of 3.9 gigahertz. Then AMD has another one called the 3800X. I mean, those are really just different bins of the same processor, and I am overclocking anyway, so I'm finding that I'm able to get similar type of performance out of it. There's still 8 core, 16 thread, so I don't really see a big difference with going with these more expensive processors than just getting the 3700X. So we've got the 3700X, and what we're going to do is we're going to run it in this setup using the Aorus B450 from Gigabyte. So we're using the exact same motherboard we use with the 3600, and we're going to see what the overall performance is like compared to the other setups. And we're using an NVMe drive, a Gen 3x4 M.2 from XPG. This is a very good NVMe drive. It's got very high throughput. And it saturates the processor pretty well. And to compare with an RX 580 for the video rendering output, we're using the Radeon RX 580 XTR 8 gigabyte. This is the highest boost clocks you can find, really out of the 580s that are out there. So this is just really to compare processor versus GPU in terms of render times. And we're going to do some other tests later, but right now we just want to compare with all the other processor benchmarks that we have. And so we'll see what the results are like. We're going to be using the program Vegas Pro for our program here for doing these tests. And so we'll be able to see what the performance is like based on our benchmark application here. Using our benchmark application, we're going to see what this output is like. We're going to go to File, Render As, and the first render we're going to do is we're going to do a 4K render using just the processors, and we'll see how long that takes. So now that our render times have settled down, just on the processor, it's going to take roughly 1 hour, 32 minutes to complete this render on just the processor. And we can see that we're using just the processor because the CPU is currently at 100%. You can see that we're showing really 16 logical processors, which is 16 threads, 8 cores, and the GPU is only at 5%. So we're not using the GPU to do the render. We're using the CPU purely to do the render. And it's doing it at 3.86 gigahertz is what it's showing right now. Let's see if that's true, because Windows doesn't always report the right number. So 1 hour, 32 minutes. Let's look at what Ryzen Master is showing. We're doing it at 3.85 gigahertz with a max boost clock of 4.6 gigahertz. So when you're rendering video, you're not going to the boost clock. When you're editing, you probably are going to the boost clock. But when all cores are engaged, you're running purely just on the threads and the cores that are in your processor. Now we're going to test to see what the render time is like on the RX 580, which is just going to be a pure GPU. and see what that render time's like. So now that our render time is settled, it's going to take roughly 39.5 minutes to output the render here using the RX 580 GPU for the render. And to verify how that works, you can see here that the CPU is only operating at 41% of the total processor activity. Interestingly enough, we're running at a higher clock even though it's only at 31%, but the GPU for the Radeon GPU is doing video encode right now and is being taken up at 100% utilization in terms of the amount of processing that's being done, because all of the video encoding is being conducted by the GPU. I don't know why it says right now it's 0%. It's probably something that Windows is kind of screwed up on. Let's see just if Ryzen Master shows the higher clock. And if you notice with the GPU being utilized, the clocks are all over the place in terms of the GPU here. Or I'm sorry, in terms of the processor, the clocks are all over the place. And this is basically like stock performance is what we're seeing here with full loads. So where does the R3700X fall in terms of the other processors? It's generally speaking, it's going to be the same when you're rendering with the GPU, with the discrete GPU. The RX 580's render time is not going to change, as you can see here. But in terms of just pure processor, it does change. It's got 2 more cores, 4 more threads than the 3600, and it shows it. It's faster at 83 minutes. It's quite a bit faster than the 110 minutes or whatever it is for the 3600. And even an older 6-core 12-thread is from Intel is slower than the AMD R7 3600. So as we get more processors to test, then we'll be adding it to this benchmark so you guys know what you're able to render with and what to expect from your hardware. Thanks, and hit the subscribe button below when you get a chance, and you'll get updates on new videos.